Hello everyone. So my name is Divya Thakur and this is an introduction to what an algorithm is. So the agenda that we are taking up in this video is the definition of algorithm, its uses, and the applications. So the definition of an algorithm is that it is a step-by-step procedure. You mean you have the first step, then you have its second step, then you have the third step. This is how you're gonna make your computer learn. So algorithm is a finite step-by-step procedure of a computational problem. So this is an example of algorithm. Suppose you need to find out the product of two integers m and n such that you are giving the input to the computer in the form of m and n both being greater than or equal to 0. So we're taking only positive integers into account as our input, and the output that we want from the machine is the product of both m and n. So we follow this algorithm. We take a variable we take here and assign it a value of 0. Then we run a for loop, and we run this for loop m number of times. What we are doing in these m steps, we are adding constantly n to p. P is 0. So if we, in this first step, we are gonna get P simply as equal to N. So just understand it like this. If you want to do product of 2 and 3, you're gonna get 6. So product is nothing but a set of repetitive additions, which means that you're adding 2 3 times. So 2 plus 2 plus 2 is gonna give you 6. This is what we are doing here. In the first step we are getting P as 2. In the second step we'll add this 2, which is the current P, to N again. We'll get P as 4. And the last step, because this loop will run from 1 to 3 times, as in the case of this example, so in the third run of the for loop, you're gonna get 4 plus 2, which is equal to 6. Since this value is getting stored into P, the computer will return to you the value of P, which is the product of M and N. So this is our result in a summarized manner. You're gonna get 0 if your m is equal to 0, because your for loop will not run, because the condition will then become 1 to 0, and this condition is false, so the for loop will not run. Otherwise you're gonna add n to m minus 1 times, right? Which means n in the first loop, you're gonna get n in the first loop, and the next run of the loops you're gonna be adding n to m minus 1 times, as we have seen. So in a nutshell, algorithms can be stated as a sequence of operations. We are performing addition there. You can perform any number of operations in a sequence on a given set of values. You were given a value as input to the computer. So these given set of values are known as input. So you're performing a sequence of operations on a given set of values, that is the input, to produce a desired set of values, that is the output. This is what our algorithm is. Algorithm can also be defined as an abstraction of a program to be executed on a physical machine. So you're not writing that for loop in a very syntactical manner in C or C++. It was just an explanation of how that machine of yours, which is a typical model of computation about which we are gonna discuss in the next video, functions or works. So now we come to the application part of the algorithm. There are various technological arenas where algorithms are being used today. In genetics, the DNA, human DNA, is being generated with the help of algorithm. In data science, to analyze the big data, voluminous amount of data that comes up. In cryptography, to write cryptic algorithms, a typical example of which is a hyperledger, blockchain algorithm, and Bitcoin. In e-commerce, like in Amazon or various like eBay or Alibaba or Flipkart for that matter. So use heinous amount of algorithms there. Even in Google search engine, they have derived their own algorithm. So this is the vast applications of it. Now an algorithm needs efficiency. Efficiency depends on these three factors. An algorithm must have less number of steps. Because lesser the number of steps, more faster will it work. Faster means lesser time it will consume. So this is the second point. It executes in a shorter period of time. Less number of steps, the time becomes short. And it takes minimalistic amount of memory. If there are going to be less steps, there are going to be less memory. So these are the 3 points that constitute the efficiency of an algorithm. So in an example, to find out the product of m and n, you must have noted that there had been m additions because the for loop was running from 1 to m. So if we need to lessen the amount of for loops, you need to first analyze how can we have these fewer additions. So we see that if m is greater than n, suppose 3 is greater than 2, then you're actually running the for loop 3 times and you're adding 2 plus 2 plus 2. But we know that multiplication is associative, which means that 2 into 3 will be equal to 3 into 2. Both will give you 6 as the answer. So to lessen the number of steps, to increase your efficiency, you can swap m and n if m is greater, because then if you swap it, you get m equals to 2 and your loop will be running from 1 to 2. That is only 2 number of times. For these 2 times, you will be adding 3 to 3, which is gonna give you 6 as the result. After swapping, you will again take a variable p equals to 0. You will run your for loop from 1 to m and you're gonna perform this set of operation of adding p to n. Then you're gonna return p. So your result obtained will be the product of m and n. There, in all, you're gonna have m number of additions and these are gonna be lesser number of additions. So you have actually improved your algorithm and its efficiency. Now, if you want your program to constitute less number of memory, you mean static memory, not dynamic memory, then you're gonna use recursion. So in recursion, what will happen is, if m equals to 0, your program will return 0 immediately. It will not perform the next number of steps. It will not wait for the for loop to become 0 and then stop the execution of the program. It's just going to return 0 and end it. Else, now this else part is important because then it's going to return n plus product m minus 1 comma n. So when your program encounters this statement, it will again go back to this statement because this is your function. You're calling your function again. Now it's checking if m equals to 0 because you have performed this m minus 1 operation here. So it's gonna check if m equals to 0. If not, then it's gonna add n to your function. We are seeing the instances here to understand this better. What is an instance first? The definition is, an instance of a problem consists of a sequence of inputs in accordance with the constraints of the problem statement. So let's analyze the instances. There are 4 instances in this particular problem. If we take m equals to 3 and n equals to 5, this will return 5 plus product of 2 comma 5 because why 2? Because this will call m minus 1 comma n, which is 3 minus 1, 2. This is the second instance of your program. Now the calling problem will be product of 2 comma 5, which will return 5 plus product of 1 comma 5. So you had 5. Alright, then you are adding it to this second instance. This second instance is giving you 5 again, and then a third instance is running. So 5 plus 5 will give you 10 already, and then your third instance of the program is running. The third instance of the program will also return 5 plus product of 0 comma 5. This 5 will get added with these 5 plus 5 plus 5, and then this calling statement, the fourth instance, will return 0. So in all you'll have 5 plus 5 plus 5 plus 0. So see, when the control will return from here, because it has finally returned 0, the control will return here. Okay, so from here you're gonna have 5 plus 0. Then your control will return to the second instance. 5 plus 0 would be computed as 5 by the computer. So now you have 5 plus 5 here. This will be computed as 10. Then your control will return to the first instance. Finally, you have 5 plus 5 plus 5 as here as 15. 5 plus 10 equals to 15. So finally you have product of 3 comma 5 to be 15. So this is how you lessen the amount of memory, amount of static memory, and increase the dynamic memory so that it can be brushed off once the execution of your program stops. Now, the second thing that we need to concentrate upon is correctness of an algorithm. How can we say that an algorithm is correct? So you have 2 points that tell you if your algorithm is correct. First, in terms of instance, that is, for every input instance, your algorithm should halt with the correct output, as we have seen with recursion. If it is not giving you the correct output at every instance, at every input instance, then your algorithm won't be correct. If it is getting the correct output at each step, then your algorithm is said to be functionally correct. Okay, so if your algorithm is functionally correct, it also needs to be computationally correct, which means that it overall solves your computational problem. It gives you the right answer at the end of the execution of the program. If it really solves your problem, then you have a computationally correct algorithm. If it solves your problem, if it gives the right output at each instance, then your algorithm is functionally correct. So the factors upon which the algorithm depends are the following: input size, okay, efficiency and correctness of an algorithm is checked on the basis of input size. How? If your input grows in size or it decreases, then how does your algorithm behave? This will tell us how efficient and how correct your algorithm is. Also, algorithm depends on time. How long does your algorithm takes itself to complete? Algorithm also depends upon space, how much working memory, that is RAM, it is consuming. Right? Now, in many algorithms, in such as in data, image, and video compression, also in case of real-time applications, you have quite a variety of algorithms. So, in data and image compression, you need to take care of bandwidth. If your algorithm is such which is being used in these kind of applications, then bandwidth or transmission size is also one of the factors upon which your algorithm will depend. Because if more bandwidth is being generated because of your algorithm due to data compression, then its efficiency can be lessened. It will not be an efficient algorithm to be implemented in these kind of applications if it's generating a large amount of bandwidth, that is a large amount of data. Response time, how is it different from time? Because time is the overall execution of your algorithm, while response time means the step-by-step execution of your input instances. If those response time of those instances are less, so your algorithm is of lesser efficiency in areas such as real-time applications. Because when you are watching a video on YouTube or wherever else you are, so you must have noticed that it keeps on buffering dynamically, and it keeps showing you the small pieces, the small chunks of data that it it's retrieving. So if your response time is gonna be larger, so your application is not gonna run that efficiently, which means that your algorithm is not up to the mark. Also, there are arenas such as operating systems. It also runs on various algorithms. So here power consumption also becomes a very important factor. For example, in calculators also, you have to compute large amount of data, you have to perform large calculations. For battery driven laptops, so if your algorithm is consuming a large amount of power, so then it's not a very appropriate algorithm to be used in that particular application. So this is all for the first video on the series of algorithms. Thank you for watching.